Hi, this is Keith from ProTutor. We have a pre-calculus homework question here. If $1,000 is invested at an interest rate of 6% per year, compounded quarterly, find the principal at the end of 1 year, 2 years, 5 years, and 10 years. Okay, so we have a compound interest problem, and the first thing we do is start off with the compound interest formula. A equals P times 1 plus R over N to the NT. Now, there are 5 variables in this formula, and really the key thing to work on with these problems is just making sure that all of the data from your problems finds its proper place within the formula. The scenario that you've got with these types of problems is usually you've got some sort of banking scenario where you're making a deposit into a bank of some sort, and the deposit at the end after some period of time is going to be worth more than what you initially deposited. Your initial deposit is called the principal, and that's why we use a P in the formula for it. And in this problem, we know that it's $1,000 that we're depositing as our principal. At the end of the investment period, the amount that the principal is worth, and that's the A, is the amount the principal is worth at the end of the investment period. The A is how much it's worth at the end of the investment period, and that's what we're actually asked to calculate in each of these 4 scenarios that we're given. The T is the investment period. Typically it's in years. Doesn't have to be, but typically it is in years. It's most intuitive to think of it in years, but just as a side note, it doesn't matter what the period is so long as the period that you're talking about is the same between R, N, and T. So it doesn't matter whether it's years, whether it's months, you could even do it days. It doesn't matter. It's most intuitive when we think about it in years, and the most common one that you will encounter with banking and things like that. So T is the investment period. R is going to be your interest rate. And again, that'll be in years. And then N is really it appears here twice. It's really the only difference that you're going to have, the only different variable that you're going to have in compound interest problems than you did when compared to the simple interest problems that you've done in the past. The N stands for the number of compound periods per year. And that kind of gets to the heart of the difference between the compound interest problems or the compound interest scenarios and the simple interest scenarios, is that if you made a deposit of $100 into a bank, and at the end of the year, and let's say it's for a year, at the end of the year they pay you $10 in interest. In both cases, let's say you would in both simple interest and compound interest, you would at the end of the first year receive $10 in interest. The difference happens is in the second year. Let's say that you decide to leave your principal in the bank for the second year, if you're receiving simple interest on your principal, then you will only receive interest off of that principal. So you will only receive another $10 in the second year. It's not the case with compound interest. You will actually receive not only interest on the $100 that you initially deposited at the beginning of the first year, but you'll also receive interest on the interest that you earned during the first year. And so because of that, because you're getting interest on interest, that's why we call it compounding. So, and typically what happens is the more often that you get interest on interest, the more money you're earning. And so that's what this N stands for in this problem, is how often you're going to get the compounding of interest. So with that taken care of, we have $1,000 in the principal that we're depositing. The amount that we're after the amount in each of these four scenarios, which is T, and then the interest rate is 0.6, and N is 4. So we can go ahead and actually write out what we have so far in this problem. And so we have A equals 1,000 times 1 plus 0.06 over 4 to the 4t. And so that's 1,000, 1 plus 0.015 to the 4t, and that's 1,000 times 1.015 to the 4t. And that's our formula that we can use in each of these four scenarios. In A, we have t equals 1 year. So A equals 1,000. It's 1.015. The 4 times 1 equals just 1,000 times 1.015 to the 4. Let's pull up that calculator. We have 1.015. To the 4 times 1,000. And we get 106136. For B, we have t equals 2 years. So A equals 1,000 times 1.015 to the 4 times 2. It's 1,000 times 1.015 to the 8. And so we get 1.015 to the 8 times 1,000 is 1126.49. In C, we have 5 years, so t equals 5 years. 1000, 1.015 is 4 times 5 is equal to 1000 times 1.015 to the 20. 1.015 to the 20 times 1000 is 1346.86. 1346.86. Finally, D T equals 10 years, A equals 1000, 1.015 times 4 times 10 is equal to 1000 times 1.015 to the 40, and that is going to be 5 times 1000 is 1814.02. 1814.02. So those are our 4 answers, and that's it.